Hello and welcome to Disruptive, the UK's first live technology channel. I'm David Organ.
And I'm Anjali Pereira. Remember, you can get involved with the conversation on social media, message us at Disruptive Live or using the hashtag Disruptive Live, or message us on Facebook as well.
And over the next hour or so, we're going to be looking at articles and things in the news that have really interested us in the last week or two. Coming up, we're going to look at SoftBank's announcement of $888 billion they're planning to invest in the tech industry. Twitter is cracking down on harassment and abuse. YouTube AI tech now flags about 83% of extremist video content using their AI algorithms. A computer model that helps us understand depression. And the world's first 3D printed bridge opens to cyclists in the Netherlands. Google is mapping the Great Barrier Reef with cameras, drones, and other NASA technology. AI that can detect breast cancer has hit a 97% success rate. And we're also going to cover Japan and America's first gigantic robot fight.
Now this is the story I've been looking forward to.
Yeah, it's well worth it. Finally, we're going to have a look at something else that's pretty interesting. The Dubai police have just announced the purchase of hover bikes. That's right, flying bikes.
The police are doing that.
The Dubai police, yes.
So we've got a great show lined up for you. As well as our news, we've got an interview with Matt Smith from SteelEye. He's going to be talking to us about the difficulties of regulating technology. So, without further ado, let's crack on with the news.
Straight on, yeah. Now, at the top of our news items today is SoftBank's announcement that they are planning to invest up to $880 billion with a B dollars in the tech industry.
I mean, this is just a ridiculous amount of money.
It's a crazy amount of money.
It's almost unfathomable.
Yeah.
So what's the reasoning behind this?
So it's making this announcement. So SoftBank is a gargantuan Japanese bank and probably Japan's richest man. Sorry, forgive me for the pronunciation, but Masayoshi Son
It's a good attempt.
has made this announcement in an interview. So the Vision Fund, which was the first step towards this, announced a 10 trillion yen or $88 billion investment. Mr. Son has said that's just not enough.
It's not enough?
Is not enough.
Okay.
So
that was me thinking it was too much, but apparently it's not enough.
Yeah. So what this week's announcement is that came out late yesterday, I think, is they are going to rapidly expand the Vision Fund 1 into Vision Fund 2, 3 and 4 over the next 2 to 3 years. And what this will allow you to do is essentially they're going to be putting a lot more money in tranches into this fund to essentially help tech companies. So they're initially looking at about 1,000 companies over the next decade or so that they're going to be putting substantial funding into.
So is this kind of a real investment? Because Son is known for his bold and provocative
statements.
Yeah, exactly. You know, he likes to say things that get people talking, and part of me thinks that a lot of what he says is a kind of a PR stunt. Is this really about new tech, or is this about kind of self...
It's probably too early to say at this stage. However, if it is a PR stunt, it's quite a good one. So he's immediately saying, right, going to put all this money into the market. Whether other people see that as traction and start putting money into the market, it might be a great thing. So,
but I mean, we've had this conversation before, you know, developing tech for the sake of tech, without having that kind of that higher level conversation about what are we actually developing, you know?
It depends at what stage in a company's sort of growth cycle or startup phase that the money goes into. So I doubt this kind of capital will go into seed funding. So it's not going to really be backing entrepreneurs who want to realize the next great idea. This is most likely going to be institutional funding that goes into established tech companies to support either growth or maybe research and development, but within corporate structures that can actually fund that research and development internally using this money.
Okay.
So the jury's out. I mean, they've got the headlines. They've announced this crazy amount of money. I mean, to put this into perspective, according to KPMG, a total of $127 billion was spent in venture capital last year worldwide.
Worldwide.
So last year, 127 billion was invested by venture capital into the tech market.
That's significantly
so
less.
880 billion is enormous. It's almost beyond comprehension.
I mean, where is that? It baffles me that that money can come from one source, from one person, from one company.
Yes, I haven't seen any details on how the funding model works or where this money comes from, whether it's going to be institutional funds, so things like pension funds and other investment funds that the bank manages on behalf of their clients, quite how it's going to be structured. I mean, this is a stupendously wealthy organisation, SoftBank, and backed by the wealthiest man in Japan. So there is no shortage of money, but that is an awful lot of money.
Well, clearly they see a return on investment coming.
Well,
sometime
hopefully
soon.
so. Hopefully so.
We shall see.
Yes.
So, moving on to our next story. This is about social media. Twitter is cracking down, finally, on harassment and abuse. So Twitter has recently publicly announced issues that have plagued social networks for years, and we know this. And the social media giants have been repeatedly criticised for failing to properly address them. But now, basically, what Twitter's done they've announced these almost 24 changes that it's going to implement from October 27th this year through to January 10th next year. They're focusing on quite a broad range of things. So they're going to crack down on non-consensual nudity, including what they call creep shots and hidden camera footage. They're looking at hateful imagery as well and violent rhetoric. And also they're committing themselves to being more transparent about the accounts that they suspend, which is interesting. They're also looking to proactively ban content that glorifies or condones violence. So at the moment, they just draw the line at actual threats of violence, but now they're going to put more into actually banning that content. And they're even going to suspend the accounts of organisations. If you have a big enough account, I suppose there's a certain amount of protection that you might have, because you might have several people, different people posting. But now they're saying, no, we're going to crack down on organisations who do this, and even abusive display names as well.
Well, I mean, we have been discussing this in the news, and the mainstream media have been discussing it for years. So for Twitter to finally come up and make this announcement, it's kind of a little late, but it is a very welcome step forward, I think. So they're going to be implementing these rules coming in from as early as next week.
As in next week.
And well, Twitter has been sort of, and a lot of social media has been a bit of the Wild West. You know, it opens people up to prejudice and abuse, because the people spouting this hateful content often think that there is an element of anonymity to it, that they are anonymous, so they're more likely to have extreme views. And now this is a good step along the way of being able to say, no, certain content will be marked, we can disable your account, we will remove your posts, if not actually know who you are.
Yeah.
Because, I mean, even the law has been making step forwards in this respect towards internet trolling and cyberbullying. So
absolutely,
it's about time.
It makes me wonder. I mean, there's a huge shift now towards corporate social responsibility. The consumer is demanding that organisations take responsibility for the world around them, for the communities around them. And classically, these large internet giants like Twitter, it feels like they're almost too big, they're almost too good for CSR. Yeah. But now, for some reason, there's been a shift, and they're paying attention to it. So I think this is really positive.
There are also a couple of elements that are maybe glossed over in something like this. I mean, corporate social responsibility great, companies being proactive, but we've seen it with YouTube and Google, and we're going to look at that in the following segment, where it's actually their revenue streams. You know, once the advertisers and the brands go, well, we can't be associated to this kind of content, and they can remove that advertising revenue, then all of a sudden these companies get a shock.
Yeah.
Much more so than the government saying they need to do better and not really having a stick by which they will respond to. So that's an interesting angle.
It's the world we live in. Financial motivation is the way to go, apparently.
And then the other aspect is AI and the machine learning algorithms that these companies have been developing are now starting to get good enough where they can identify this content much quicker than before.
I mean, this is something that Facebook has repeatedly said. We don't have enough people, enough manpower to physically go through the abusive messages or, you know, the content that shouldn't be there. We just can't do it. And so that's why they're looking to AI and machine learning to help.
Yeah, and people need to understand that it's just a huge amount of content, especially when you're talking about videos that needs to be gone through, that it has to be done using AI tech.
Yeah.
So there could be a couple of things sort of reading between the lines on a statement like this, as to why they're doing it, why it's taken them so long. But it's well overdue.
And Twitter's not the only company doing it.
No,
as we're going to talk about now.
Yeah, staying in the same vein. So YouTube and Google have announced that their artificial intelligence tech now flags about 83% of extremist videos that get taken down.
It's quite impressive.
So this is actually up 8 percentage points from the last sort of reference point they had, so last month, essentially. And what they've been doing is they've been taking a group of moderators, so these would be actually people going through about 1 million videos and essentially training through machine learning algorithms the artificial intelligence on what is extremist content as opposed to, you know, what's a fluffy kitten rolling around in the grass. It's probably a poor example, but anyway, so they are showing improvements as well on this front.
So this is interesting because on one hand, this is really good news. 83% is a very high percentage. However, the other part of this story is that the algorithms are mistaking content that's not violent or extremist as extremist content.
Yes.
For example, British researcher Elliot Higgins complained in August this year that YouTube had deleted his videos about Syria without any warning, thinking that they were terrorist related. And American journalist Alexa O'Brien's channel was reportedly suspended as well because that was mistaken as a propaganda outlet. So the AI is not perfect.
No, well, you're always going to get false positives.
Yeah.
So as the algorithms improve through machine learning techniques, you want to drive down the false positives, but also not let any sort of slip through the net. So the balance between missing content that should be flagged extremist against flagging content that isn't extremist as extremist, you're always going to have a certain proportion. And really it's going to come down to, you know, what level, what percentage are we happy with? And these companies need to make sure that there are also appeals processes or some kind of framework where it can be passed to a human moderator if the person posting the video has a legitimate reason to say, hey, this isn't extremist, this was a report that we actually did from Syria looking at the issues, then that would be welcome. But there are always going to be teething problems. They can't satisfy everybody 100% all the time.
And it's incredibly difficult. Some of these things that, you know, they have to identify, they're so subtle and they're so inherently human. Things like, you know, sarcasm or references to things. You know, that's something I think that machine learning is and AI is still struggling with. And I just don't think we're there yet.
We're not. And I think AI can't be the only tool in their arsenal. Agreed, they don't have enough manpower in the world to go through the amount of content that gets uploaded every hour, let alone every day. So there has to be a balance between using the AI as a tool and then having people as a final sort of quality control or moderation layer, especially to allow for an appeals process for legitimate content.
Well, I mean, moving on to a story about the success of computer models.
Yes.
This is something that obviously I'm interested in. A computer model might be helping us to understand depression. This story is about computational psychiatrists who have broken new ground in understanding how humans learn by modelling a software program that behaves just like humans. And this study was led by Oxford University. And what it's doing, it could actually help to explain why people with depression are overwhelmed with negative thoughts.
And a lot of this is to do with the amount of weighting, the importance we put on negative thoughts over positive thoughts.
Precisely. So what they did during the study, participants had to choose between two shapes that flashed up on a screen. One shape earned them money and the other one would take it away. And the researchers designed this task so that either the positive or the negative outcomes were variable, so they changed quite unexpectedly. And they looked at how people reacted to that. They wanted to know whether there was a tendency to alter how we prioritise the processing of our thoughts, of positive and negative thoughts, and whether that can bias our beliefs. And this is the first study to prove that people separately judge how information can be good or bad depending on an outcome. So essentially, people with depression prioritise negative experiences as more important because they feel that they learn more from it.
Right. So is it about the learning process or the reward, the outcome?
So it's essentially saying that there is an advantage to learning from an experience. And you can either learn something from a positive experience or learn something from a negative experience. And if you put more importance on the negative experience, the logic is you then focus more on the negative experiences in your life, which may then lead to this clinically depressive state.
Right. So the creation of this computational model, is it designed to help further our understanding of how people with depression actually work, what the sort of the thought processes are, and where they go wrong, with a view to improving therapy or clinical support?
It's more about understanding how we react to different outcomes in our lives. So what this mathematical model did was complete the same task as the humans, essentially. Right. So they had parameters that changed depending on what the computer learned and how much the computer itself was interested in winning or losing. And then the researchers altered these parameters so that the computers behaved as much as possible like the individual human participant. What they found was really interesting. So humans learn more, according to the study, when events have volatile outcomes. Okay, so if the outcome is unexpected, if it's variable and it can change, we learn more. And depending on whether you think that a positive experience can have that volatile outcome or a negative experience can have that kind of alters the way that you think. And the idea, possibly, is that by helping people with clinical depression to see positive outcomes as being volatile, as being variable, it could help them to see it in a completely different perspective.
So sort of balance things out.
Yeah.
So it's not just about taking away the negative inputs, it's about raising up the positive inputs to be as important or more important. And that's to do with the volatility, that it's quite chaotic.
Yeah, it's a really interesting kind of comment on the way that we think and the way that we learn. Obviously, there's an evolutionary benefit to us learning from our experiences. And if we can alter the way that we learn and prevent mental health problems at the same time, then it can only be positive going forward.
Yeah, I suppose from an evolutionary perspective, a negative outcome you might put a bit more weight on because, hey, you don't really get that many chances if things do go wrong.
only
Whereas
get
when
eaten by
things
a
work
saber-toothed
out,
tiger once.
it's like, hey, I've got a full belly tonight, rather than being eaten by a saber-toothed cat or something crazy.
Exactly.
Right. Well, okay, so just to change things up a bit, we're going to move away from AI and computational models. And the next item is essentially we've created the first 3D printed bridge. It's been open to cyclists in the Netherlands. And what this is it's an 8-meter long span that crosses 2 water-filled ditches and roads. And it's made up of thousands of layers. I think about 800 layers of concrete that has essentially been printed as part of the production process to create this bridge.
They printed a bridge over a ditch. Is that what you're telling me?
Yes, and it took them 3 months.
3 months.
Yes, so the bridge has some 800 layers, and it took 3 months to print, and it's made of reinforced pre-stressed concrete. This is in the southeastern town of Gemert.
Okay.
I think I pronounced that right, but I'm sure my Dutch friends will correct me. And it's been carried out by a university. They said one of the advantages of printing a bridge is much less concrete is needed than conventional techniques, which use kind of a mould approach.
Okay.
So you use shuttering and moulds to create either building pieces, like components of the bridge, or they will build the shuttering over a structure and then cast the entire bridge.
Okay.
So
this is less wastage in a way.
Yes. So they say.
Okay. I mean,
because it only deposits concrete where it's needed.
Okay. I mean, they're not the only country. The Netherlands are not the only people looking at 3D printing technology, are they?
United States and China are also taking lead on this type of 3D printing, using computers and robotics to construct objects from scratch. So there is a lot of interest and investment and money going into these places. There's even a Dutch startup called MX3D, which has begun printing stainless steel bridges. So we've got concrete printing capabilities. Now we're going to go to stainless steel. And apparently it's already underway. They've got a third of it completed. And the aim is to finish printing by March, so they can lay the bridge over an Amsterdam canal in June.
That's incredible.
Yeah, so it's not the fastest process, but then when you look at traditional building techniques, they're not always the fastest anyway.
No, and if it's true that there is less wastage, then perhaps there is a motivation behind it.
And you know, this is the dawn of a new technology, so I'm guessing it can only accelerate from here.
Yeah, who knows what we'll be printing in the future?
Who knows? Probably everything.
You know that scene in The Hitchhiker's Guide to the Galaxy where they're printing food?
Yes.
Yeah, the food just appears in the little machine. I'm waiting for that day.
A bit like the Star Trek replicator.
Yeah.
Yeah. Dinner, please.
We're going to cut to a very short break now, but join us afterwards because we'll be talking to Matt Smith from SteelEye. He's going to be telling us a bit about the regulations around technology. So don't go anywhere, we'll be back soon.
Hello and welcome back to Disruptive, coming to you live on social media. Remember, please get involved in the conversation. You can find us on Twitter using the hashtag DisruptiveLive or message us on our Facebook page.
Yes, and we are very lucky. We've got a very special guest in the studio today, Matt Smith, who is the CEO of SteelEye. Matt, welcome. Thank you so much for joining us.
Yeah, thank you for having me.
Please tell us a little bit about you and about SteelEye.
Sure. So SteelEye is a cloud-based financial markets regulatory and compliance platform, and we're really here to help drive complexity and cost out of the burdens that many financial firms are facing around the world today in order to conform to these regulations. My background's technology. I spent many years working in financial services as a chief information officer for a global trading house. It was a very large firm, and in there I learned a lot about ways that we can use innovation to drive cost out, and I also feel very strongly and passionately that we can pass on some of those learnings to the market and help other firms achieve some of the things that we managed to achieve.
So, Matt, I mean, a lot of companies look at compliance as a burden, but what's your viewpoint? Is compliance friend or foe?
Yeah, that's a good question. This is something that we've thought a lot about. Now, one of the taglines that we use at SteelEye is, don't just comply, compete. And we really believe that. I think the real answer to it will boil down to how firms approach some of the problems that they face. Historically, compliance organizations and technology groups that are trying to solve these challenges would look at it in a very linear way. So as we look back over time of financial markets regulations, I mean, there's dozens, hundreds of these things that have come out, but the big ones recently was MiFID I, which came out in 2007, and firms addressed that. And then soon after, we had Dodd-Frank come out in the US, and again, similar challenges, but firms addressed it independently. Then Europe came through with the EMIR regulation and the REMIT regulation. And again, linearly people attack these things, and the Market Abuse Directive, which came out in July last year, a whole raft of firms again just did this independently. And then you now have MiFID coming into effect, MiFID II, which is the most expansive financial markets regulation in history. And we really believe that if firms focus on solving the problem right this time, that not only will future regulations become easier to bear and to conform to, but there's a huge amount of value hidden within that data. And we have built a platform that helps firms bring that data together and find that value.
So instead of it being a pure cost center, must comply in order to keep trading and satisfy the watchdogs and the regulators, now it can become a profit center. You can actually discover valuable insights within the data.
Absolutely, and it's not just about, and there certainly are a lot of commercial potential opportunities to come out of the data, but there's operational efficiencies that can be achieved. We actually have an advert coming out in British Airways Business Life magazine in November that is really about looking at MiFID II as not being a burden, but being as potentially one of the best things that your firm will ever have to do in terms of helping you drive those efficiencies and achieve value from your data that would otherwise be fragmented all over your firm and never leveraged dormant data stored in disparate sources, never to bring value to a firm.
Wow. So how did you get into this? What's kind of the pathway and the journey that you took to get to this position today?
Yeah. So I mean, my journey started a long time ago. I spent my entire career in IT and worked my way up to Chief Information Officer, and we had a very large business. It was a $100 billion firm, and we had offices all around the world. And the CEO came to me and asked me to build a data warehouse. And the problem was just this: he had disparate information all over the place. So I got my team together, and we met in a room in Hong Kong, actually. And there was about 7 of us, and we had a mix of talent. We had technologists from the banks, we had technologists from media, from Amazon, and we sat down and looked at the problem differently. And that was, we didn't look at the problem that the CEO was trying to solve. We looked at the data. And I laid out some principles as we went about the journey. And number 1, it was, let's understand our data, because technology and data sometimes don't align. And let's make sure that we pick technology that makes sense for the data that you're talking about. So we ended up with having multiple different data platforms. So we had some Cassandra, which is the Facebook database, and some Hadoop. And we looked at reference data and operational data and trading data. And then we built a whole application scaffolding platform on the top of it. And at the end of it, we realized we had something really meaningful, more meaningful than our firm would ever have been able to understand. And a long story short, at one point we all ended up finding ourselves out of that firm, and we went to rebuild this technology stack. I ended up actually going to a big financial services software house, and my team rebuilt it. And they were backed by a very large brokerage firm in the UK. They took the collective learnings of everything that they would do differently from the first time and applied it to this. Now, the first thing that they ended up learning was that these NoSQL technologies like Hadoop and Cassandra have no indexing capability. So there's no real way to search it. So they creatively came up with an idea of wrapping it with a search database. And that was where our users interacted with and they do today with the data, which is hugely efficient. We can work with billions of records as efficiently as we can with 5. And we then learned actually there's no real value for us in this scenario to have some of these NoSQL technologies, so we stripped that out. So we started to simplify it. One of the other principles that we wanted to apply was to drive cost out, and we could do that with cloud, and we should probably talk a little bit about cloud and what it means. We really believe we've taken very complicated problems because of this data platform, heavily simplified them, and driven huge amounts of cost out. And firms that are using our system now are reaping the benefit of that. And then you go back to all the valuable insights they get. It's pretty exciting.
So there's a lot of new technology you're introducing to solve traditionally quite an old regulatory compliance problem. I mean, how do you sort of see the movement from companies that use the old systems? You use the old systems yourself in your background, to implementing these new technologies? Do they come to you and you say, we've got the whole stack sorted, or do they have to kind of move across in a phased fashion?
Well, it's really fascinating, because the challenge that the firms that are our clients have to face, and this is really every financial firm in Europe, and even ones participating in Europe from other countries around the globe, is they have to build a data warehouse. They have to do what I had to do in my last firm. And many of these firms have tried and failed. Some have never even fathomed having to take this on, but they have to do it. So if you took the traditional technology route, you will end up where many historic firms have ended up, which is a very painful, costly, expensive, and complicated exercise. And likely you won't succeed on the back end of it. By taking the collective learnings of years of failure and applying it to new technologies, we're able to actually succeed in this, and succeed in it in ways far beyond what firms would have ever fathomed possible years ago. So I think as companies start to look at these new technologies, they will be able to achieve their goals. They have a very short time window in which to do so. This regulation comes into effect in January 3rd. Mm-hmm. Now, the regulators are saying there is a bit of a window, but they don't have much time. And this is some of the incredible value you get from cloud, right? We talk about cloud and the speed at which we can integrate and onboard, because it's a cloud-based platform, is, we can cut months, 3-6 months out of a project. If a financial firm went to buy hardware and put it in their data centers, that can take months on its own. Yeah. And we start from the pretense of the system's there and ready to go. Now it's about getting your data from its source into our consolidated engine.
Do you find firms are open to the cloud, or is there a little resistance? Do you have to persuade people to do it?
It's again a really good question. It was one that we wrestled with in the early days. And earlier versions of the platform could be cloud-based or it could be on-premise. And we had to make a decision whether or not we go all in. And we went all in. And the reason we went all in was we felt that we could get the best value for our clients from a cost perspective. You add in the speed of execution, that helps as well. And to the old debate, do people feel comfortable going to the cloud? I haven't come across a single firm that we've come to that has said no. And more importantly, you talk to people about private cloud and their own data centers or comms rooms and AWS and Google Cloud and Microsoft Azure. Microsoft, Google, and AWS will invest more than any of the smaller private clouds could afford into security, because it's at the heart of everything that they do. And I think as firms start to get more comfortable with that and realize, actually, forgetting your compliance data, a huge portion of our services around the world go through these data centers, that why would you be afraid of it? We encourage firms to brace it, not just because we're a cloud-based company, because it is the way that you're going to be able to solve your problems more efficiently at a far lower cost and more rapidly.
And I assume a lot of these corporations are international in nature. So if you've got to consolidate the data, it makes sense to do it in an environment that enables consolidation, as opposed to having disparate data centers connected through a patchy network.
Yeah, sure. And the freedom that you have in the cloud, if you use a service like Amazon, there's a lot of debate about geo-sovereignty of data and where that data is stored. Because we're a cloud-based service in Amazon, our clients can put the data wherever there's an Amazon cloud. So you want it in the UK, it can be in the UK. You want it in North America, it can be in North America. You want it in Germany, sure. You want it in Singapore, great. And we can set that up as easy as it is to set it up in one location in a dozen locations.
Well, Matt, it sounds amazing. Just before we wrap up, is there anything that's coming up that's happening with SteelEye in the next few weeks or coming months?
Yeah, I mean, there's a lot of exciting things. We've just had a phenomenal response from the market. Today we announced a partnership with Ernst & Young, where we're part of their fast growth support group. They recognize the speed at which we're growing, and they're helping us make sure that our business is structured well, but also that we can execute in the market as fast as possible. We have had a great response from our clients, and we're doing some really neat, innovative stuff in data analytics. I'm really excited about that. I think, in the next 6 months, even though I see us having some of the best data analytics in the regulatory and compliance space, the things that the engineers have in the pipeline is just absolutely phenomenal. So we're really excited. We're excited now. We're excited about the future, and yeah, it's great.
We're going to have you come back on for an update.
Yeah, absolutely.
Yeah, that'd be wonderful.
Matt, thank you very much.
Thank you. Thank you for having me.
We're going to go to a short break right now, but join us in a few minutes and we'll carry on with the news.
Welcome to Disruptive. My name's Alan Behrens from Taxel, and today I'm joined by Hugo Fines from Electric Imp. Welcome, Hugo.
Thank you, Alan.
Hugo, why don't you just give us a bit of background on your company, who you are and what you do?
Okay, so Electric Imp is an IoT platform company, which is the most overused phrase in IoT. Essentially, we specialize in secure communications, so connecting devices in the field securely to cloud services.
Right. Give us some ideas to, your view, because you've got a lot of experience in obviously the domain of IoT. The state of the IoT market seems to be booming at the moment. There's a lot of talk about it. There's a lot of press and activity. Give us your sort of sentiments on that. What's happening?
So, I think there's always been a lot of IoT hype. And I think we were supposed to have crested the peak of the hype cycle, but it's hard to tell. I think some of the stuff with IoT is there's a lot of activity. There's always been a lot of noise. There's been a lot of noise in the consumer space. Right now, I think there's a lot of maturing solutions for industrial and sort of proper business uses, actual uses that have some ROI attached. And so I think it's like, I don't know, Electric Imp was founded 6 years ago. And we were worried we'd be too late for IoT, but it turns out we're not. We were, if anything, a little early for IoT. But I think a lot of the really useful applications take many years to really actually develop and mature. And IoT is one of the problems is it's not just a technology you can use in isolation. IoT is transformational to a lot of businesses, and a business does not re-engineer its structure and income model and streams and partnerships overnight. It's not just like a chip turns up and it's like, oh, now everything's fine, we can do IoT. And a lot of the time, actually, the digesting IoT, digesting what connected device means, what connected devices mean for a company, is a much longer process, is a multi-year process and very complex and involves lots of partners. And so what we're seeing is that there are some early people got to market, especially with consumer devices, which were typically simpler and had remote controls for things, a smartphone controlled X. But those came out in the past years. There were some good applications. I mean, the Nest thermostat was one I was involved in, which I think had a real reason to be. It's like, it can save you money by knowing the weather and adjusting heating patterns and so on. But a lot of the more complex applications, especially industrial, are much harder to nail down than a simple use case. And so it's taken a while. But it is actually, I think we've got to the point now where people have played with this stuff enough. They've got an idea what IoT can do for them, and they're just getting to the implementation now and really understanding how it's going to work for them.
In the world of sort of manufacturing, there are obviously many different companies, different verticals, high tech, discrete manufacturing, automotive, aerospace, etc. Do you notice any particular trends on the assimilation of IoT in any of those verticals? I mean, are there any particular nuances that you got ideas on?
I mean, there are quite a few. I think there's. I mean, every industry has its own particular applications, which are, the ones which are more amenable to being connected, I suppose. A lot of ones where efficiencies are very important, manufacturing efficiencies are very important, that they've evolved manufacturing processes to use data already, maybe in a local sense, and data historians and the type of industrial control system setups. And I think that these guys have the shortest path to IoT. Because they have an idea what their data does. Maybe they want to connect some more stuff to collect more data and optimize on a larger scale, a macro scale, as opposed to sort of the close-in single machine at a time. So those guys are people we see sort of moving first, because if you've never connected one of your machines or one of your processes, you don't know what you're going to find out. And so there's a long discovery process, which is, well, you connect it and then go, oh, I wasn't expecting to see that. And then you have to dig deep into all this stuff to try and work out how this is going to bring value to you or increase your efficiencies. But I think as with most industries, that there are kind of leaders who understand their processes, and a lot of the time it's the people who have to run on very low margins and very high efficiency businesses. They're used to squeezing this stuff out and knowing everything about a process, but there's a huge amount of manufacturing where they haven't had to do that yet. Yeah. And competition is probably going to force that to happen.
Right. I mean, manufacturing, obviously, you know, the high capital cost of equipment within a factory, for example, and a lot of the equipment is very old. Yeah. So, what are your thoughts on how people would migrate what they have as legacy to be connected and operational within the world of IoT and industrial IoT in particular?
I mean, I think there's a couple of approaches. I mean, as you noted, you know, when you have machines lasting a long time, they're amortized over an awfully long time. They're often very expensive machines. People are not going to buy the latest one with connectivity, even if it exists. There are some ones which are fairly easy kills, which are things like, you know, machines which are run by PLCs, somehow machine controlled. Often you can actually just instrument the PLC and essentially do a read-only integration where actually you're sampling the registers on a Modbus device, for example, and sending this to the cloud and doing analytics on it there. But it's read-only, which actually makes a lot of factory people less nervous because it's like, you're not going to connect my machines to the internet, you're going to break something. And you know, generally manufacturing is you know, you try and keep all the dependencies within the four walls of the factory because, you know, it's foolhardy to rely on something intangible like Amazon. But I think there's those ones are going to be the easiest ones. There are some retrofit opportunities for other machines where things like vibration analysis for early failure warning, for example, is an easy retrofit. You know, you're not interfering with the process, you're not changing the machine, you're just looking at sort of side channel things like vibration. And correlating that with failures and so on. And there are companies that actually use our platform to provide these type of services. Yeah.
And that's to do sort of proactive system maintenance and you know, instead of being reactive to breaks.
Yes.
They can estimate break fix, you know, a bit more easily.
Yeah, and it is even just, you know, being able to schedule maintenance at you know, when it's needed, and not when the machine is in use, just simply because, you know, if a machine goes down, then the whole line may stop because, you know, everything has to be running. And so those type of things, there's a good ROI for them. People understand how much a failure costs. Right. And so they have a good, if they're adding some IoT, adding some sensors, adding some data analytics, can predict a failure, they understand what that's worth to them. And it allows them to drive more efficiency and maybe not have to have so many spare machines, not have a spare line. Which can help a lot.
Right. What about the thorny issue of security? I mean, everybody talks about security. Everybody's very concerned about the Internet of Things and the industrial Internet of Things and security aspects. I mean, are these real, tangible fears? Are they false?
No, there's really they're real fears. Yeah. And I think a lot of people have got away with stuff for a long time. I mean, you know, there have been connected devices, connected PLCs. And they've been hanging out on the internet and hoping no one has found them, kind of up until now. And there've been an awful lot of talks at DEF CON, one of the hackers conferences over the past few years, about exposed industrial control systems. They're real fears. It's justified. You know, it could actually cause large amounts of damage, even mechanical damage to machines if they're interfered with. Centrifuges in Iran, I think it was, which had a state-sponsored attack against them. So that there are real fears there, but it's not an unknown field. Essentially, you know, security is a pretty well-known thing, especially in enterprise sense. There are good techniques that can be taken from the IT realm and applied to OT. But I think one of the critical parts and one of the reasons that Electric Imp exists at all is just essentially good security. You don't need to be a specialist yourself. You just need to know a specialist. Right. It's no point engineering your own security. You know, when you secure websites, they all use HTTPS. They're using a standard protocol and so on. It's not like, well, this bank has got their own security they made themselves and it's different from the other bank. Everyone just goes, okay, this is good enough. This prevents certain classes of known attack. And we'll keep you and your money secure. And the same thing for IoT. You can use standards. You need to implement them well. You need to understand them to be able to build on them. But that's what we provide. We provide a secure platform so people can worry about their data, because people know their data. We don't know what their data is and what it means,
Right.
but we do know that they want it taken from point A to point B and vice versa, without corruption, loss, interference, all the things like that. So I think security should be worried about, but it's not necessarily something that you need to hire a security expert, even if you can find one.
Right.
It's because it's not like you have to engineer your own solution. You really should use stuff which someone else has done before.
Good advice. I mean, you mentioned standards there. I'm interested in what you think of the world of standards within the domain of IoT and IIoT. I mean, is it something that's incredibly important, or is it early days, or what's happening there?
I think it'll be early days for about the next decade.
Right.
I mean, I think maybe 5 years ago, people talked about IoT, and it was like, oh well, when there are standards, it'll all take off. And they were going, well, how does your toaster know how to speak to your oven? And it's like, what would your toaster have to say to your oven anyway? A lot of the time, in industrial IoT particularly, it's not really necessarily about machines communicating directly, because that's been sorted a long time ago. PLCs, Modbus, things like real-time Ethernet, stuff like that for process control has been done. And you don't want the internet involved in process control, really, because that type of stuff can be safety critical. It's highly optimized. It's process-centric. However, when I'm taking this data and throwing it up to a cloud service where I'm going to do maybe some analytics on it, or maybe some machine learning, try and see patterns in the data. Now I'm just moving non-time critical data. It has to be, in a fairly transportable form, and compatible with what you see in the cloud. So I think for that, then you can just go, we'll just use web standards, RESTful APIs. You can use enterprise message buses. You can use things like AMQP. You can use things like MQTT, but you don't need to. And a lot of time people just use RESTful APIs because it works, it's known. There are huge numbers of tools for building, debugging, optimizing, and scaling systems based around web technologies. And if you look at all the data analytics companies, pretty much everyone uses RESTful APIs for ingestion. And you can't go, it can't scale to IoT scale. It's like, well, it's already doing billions of requests, probably a second around the world. It can scale. It may not be the most efficient, but actually servers are way cheaper than engineers. So people just throw a few more servers at it and solve the problem that way, because really it's results driven.
Yeah, and they're not necessarily on-premise servers, of course. No. These are cloud servers.
Yes.
So it's just buying some more time or some more resource from your friendly service provider.
Yeah, and I think some of the stuff here as well, I mean, I have this sort of bee in my bonnet about connectivity, and that, people go, you can't rely on the internet. And it's just like, well, you can make the internet more reliable if you need it. I mean, there are plenty of people go, well, what if this internet link goes down? It's like, well, get an LTE backup. Maybe get 2 LTE backups, because actually the cost of, even industrial grade LTE routers is minimal compared to the cost of trying to engineer software which will work offline and connected. So actually it's just like, well, actually it's easier to just throw more connectivity at the problem, have 2 different hotspots wired into the Ethernet network and a fiber connection. And if one goes down, well, you can keep on operating. And I think that's something that there are different ways to peel the sort of complexity of these issues.
Right.
But you just do it very pragmatically, and just what's going to get you out of a hole. And I think there will be iteration on this stuff always. But if you're going to say, oh well, the internet's unreliable now and is always going to be unreliable, it's like, no, it's getting, people rely on it so much now that people are invested in making it reliable for everyone. I mean, if the internet goes out at any office, you might as well go home. There's no work you can do. The same will happen eventually in manufacturing, probably. Just simply because the value it provides is enough that it's worth making it reliable and making it work all the time.
So, obviously one can understand the enterprise piloting projects for either industrial internet or IoT product-based products. How about the smaller businesses? The small, medium enterprises, perhaps less so the medium, because perhaps we can classify them the same as the enterprise with their resources. But the smaller business, how does one get going? I mean, what sort of things should what would your advice be on a sort of small 100-person company on looking at how they can connect their business or their products?
So I mean, I think there's no reason why small companies can't make successful connected products. A lot of connected products are going to be built with building blocks from other people, whether it's an analytics building block, whether it's a connectivity building block, whatever. There's very few people actually have the time. They may have the money, the enterprises, but very few people have the time to build stuff from scratch. And so I think you see a lot of what you see in the standard internet industry of building blocks being put together, solutions being built out of existing proven technologies. And so that is very amenable for a small business to go in. I mean, you still need someone to champion this stuff. You still need someone who understands the technology, not necessarily every detail, but they can look at the big picture and go, well, if I can get this data at this rate into here, then I can do something with it and provide value. So I don't think there's any reason that people can't. I mean, I think, you look at some of our customers we've had in the consumer space that have been 3-person startups, and actually, Petasense, who's the one who actually do the vibration analytics, sort of a Bay Area-based company. I think there were 3 people when they started, and they shipped their first proof of concept products when there were 3 people. They're bigger than that now, but it wasn't an impossible task to build an IoT product using our platform and some other software sort of licensed and basically doing the integration and building a connected product with it. I think the good thing about a small company is they generally have much clearer definitions of minimum viable product and what is the definition of success. Whereas the bigger the company, the more these things become just political problems and struggles for control, and then they find it hard to actually make a cohesive product because there are too many people trying to give input.
Right. And I suppose, one has to sort of take that to the providers like yourself, software and hardware providers. I mean, is this the world of the big monolith? Is this the world of Google, Amazon, Microsoft, and IBM? Or is it the world of the innovator like yourself? I mean, what's your view on that?
I think there's a place for all the different sizes of companies. I mean, we're a fairly small company with just over 50 people. We specialize in one part, the connectivity, security, and lifecycle maintenance, and lifecycle security as well, which is, some people look at it, and a lot of the bigger companies have actually looked at that, the IoT all the way from the thing to the high value analytics or business intelligence or machine learning, and they've gone, oh well, we can see there's a lot of value in the data, and they've put a lot of time into all those data, lots of data scientists and so on, and Hadoop clusters and all this stuff to store huge amounts of data in. And they've gone, and someone else can deal with the things down there. And they've kind of, well, the silicon vendors make chips, that'll do it. As a networking chip, it'll do it. But actually, there's millions and millions of lines of software required to do that bottom bit. And I think actually this is good for us because we're actually in the right place to provide value to the bigger customers, the bigger companies that don't want to go into the messy, dirty world of the real world, security patching, stuff like that. And so there's a combination. I think it's hard to be a general, fairly broad horizontal data platform as a small company. People like Microsoft can get away with it. But if you're a small company doing particular analytics for, say, oil and gas, I think you can do that, because the point is that Microsoft is never going to put enough effort into oil and gas. But what you'll find is you probably have multiple layers. You might have us doing connectivity, Microsoft doing data ingestion and sort of first level analytics, and then someone else selling a package on top of the Microsoft infrastructure to provide the vertical specific value. And you have these combination of parts that will just work well based on open APIs at every level.
Yeah. So I mean, I suppose, you having said that, there's obviously a lot of opportunities for software developers to create custom application, vertically focused applications to add value to specific markets. Yeah,
and I think that's always been the way, that there are the people who know their markets best, are the people who understand how to extract the value. And that's kind of always true, is that there's every problem looks simpler until you're actually in that industry, and then you go, it's not quite so easy as that, it's much more complicated. And we did that for connectivity, and we specifically stayed out of data because we were worried that was actually a very, very complicated field and we weren't going to add any value there. But you did find some IoT platforms which did connectivity and a bit of light analytics on the side. But it really was light analytics. It was like, we'll store the data and draw you pretty graphs. And graphs are not analytics. If your brain has to look at it, you have to have a human looking at it and seeing a pattern, then it's like it's you doing the analytics, and the other one is just storage and graphing. Right. But I think there's always almost every industry has an incredible amount of depth and knowledge built up over the decades about how a process works, about how to make something reliable, whatever else, how to make something efficient, and those people will become more valuable because they're going to have to teach the machines essentially, the salient points of how to do something well, because machine learning generally needs training. You've got to give it some target to optimize for and whatever else.
Yeah. I mean, I suppose as a sort of final question, have you got any advice as to things that you would recommend people do to get going? I mean, there's a lot of companies out there who haven't actually done anything, who are thinking about it, very excited by the prospect, not quite sure how to get going. What would your advice be to those companies?
I mean, I think the main advice is to do something. A lot of the time, if you don't have anything connected, you don't know what you're missing. You don't know what the value might be. So it doesn't have to be an expensive thing. I mean, really, we've had customers who've come to us and the first contact with them has been an intern. They got them for something. What can we get them to do? Well, let's get them to, get some data onto the internet and draw some graphs of it or something. And they've done this at very low cost. They've given the intern a budget of a few $100s or something, and they've soldered something together. They've got and they've got some data, and they've gone, oh, that isn't what we expected. And that sort of thing. The problem is you don't know what you don't know, and I think it's the main thing is you have to start somewhere. And it's the people who start off with the grandiose plans of we're going to connect 1 million devices, and hence we need to architect our backend correctly to deal with this and that and that. When they don't even know what data they're collecting, it just slows the process down. You should do it in baby steps and just iterate. And I think iteration is always a good thing in almost any industry. But with IoT, it's important not to over-design as well as not to under-design. And you can iterate. You can start with a secure platform and iterate your solution on top of that, and get to the point of, well, actually, even though I've built one of them, and then I roll it out to 5 devices at 5 customer sites, for example, and it's so good, then I want to do 1,000 or 10,000. You can do that all on the same platform. That's the kind of nice thing about this stuff, because cloud stuff scales very well. And I think it's good to actually start with something which is designed to scale up. You can do things that people do, they connect stuff with a Raspberry Pi or whatever, and it's like great. It's great value for money. You can put it all together. It's not secure. It's very hard to secure a Raspberry Pi, physically especially. And some people prototype with, I think, the wrong solutions because there's no clear path to production. And that's I think we call it like the POC gap. You get the proof of concept. It's like, great, let's make more of them. And it's like, oh, we have to throw it away and start again. And then it's a complete reset, and that that dampens the enthusiasm and reduces the momentum. So don't want to blow our own trumpet too much, but there are other platforms, not just ours. But I think it's a good thing to have a platform. Basically write as little code as you can. Right. Always, and any line of code you write is a line of code you have to maintain. So the less you write, the better. And that's universally true in almost any engineering thing. The most elegant, simplest solution is the best because it's most reliable.
Absolutely. Well, Hugo Fines, thank you very much. I think you'll all agree that this was really interesting. I'd like to thank you for your time and your insights, sage advice. Thanks for listening to Disruptive and watching Disruptive, and we'll see you next time. Thank you.
Richard, in a year almost, discovered a whole reef in American Samoa that got bleached. So looking at the Great Barrier Reef and seeing the localized effects, or if it's a global effect affecting the whole reef, this technology will help us understand that.
I mean, it's interesting that you talk about Google Street View, the power of using cameras, the power of an image. You know, they say an image speaks 1,000 words. Maybe by doing this not only helps scientists with their research, but also help the world to understand what's going on with the reefs, what's happening underwater. You know, we take it so much for granted that our oceans are this constant. But if this allows people to see a visual representation of what we are doing to the coral reefs.
Well, this combined with the campaigns, the whole Sky Ocean Rescue around plastics, is such a great thing about raising awareness. I mean, the oceans are vast and they're considered to be a limitless resource.
Yeah.
But it's also remote to us. We live on land. The vast majority of people don't dive. They don't get to experience these places. Going to the Great Barrier Reef and diving there is probably one of the most wonderful experiences you can have, with the colours and the biodiversity. But this makes it tangible. People will be able to log on and perhaps even cruise down the Barrier Reef in its current state of health and experience that biodiversity and that wonderful natural resource that we have that they previously might not have been able to experience.
No, it's a fantastic project. I mean, I just hope that it makes a difference.
Well, yes, I mean, global warming and acidification of not only the seawater but the rain are major issues that need to be tackled with a lot of the clean technologies that we cover on this show. So the more popular interest there is, the more demand for renewable power sources, electric cars, things like that, that all ultimately contribute to the health of both our atmosphere and our oceans.
And our species.
And our species, yes.
Absolutely. Oh. Well, I mean, I really hope that this does make a difference, because that's something I feel really quite passionate about. People watch movies like Finding Nemo and kind of presume that that's the way it is, and that's the way it's going to always be forever. So, yeah. Moving on to actually another human health related
Well, this falls
story.
Well within your area of expertise.
Yes. So we've got AI detecting breast cancer risks that has a 97% success rate. I mean, that's
fantastic.
An incredible
and what
number,
a great
isn't it?
application of artificial intelligence.
So we already know that when it comes to recognising patterns, artificial intelligence tends to be far better than humans.
Yes.
You know, they don't get tired, they don't make mistakes, they can notice fine details that the human eye may just miss. And what's interesting about breast cancer is the way that it's diagnosed is, of course, after you have your initial consultation and your examination, you might have a mammogram. And what's picked up on that mammogram can be tiny little calcifications, little white spots that show up, or little cysts, even things like fibroadenomas. But the problem is all of these things can either be benign or they could be malignant. And so women go through surgeries, biopsies to see what this tissue is, to remove it just in case. Sometimes even choosing to have the breast removed altogether to prevent that risk. But in a lot of cases, in fact, MIT, let me just find this statistic because it's insane. According to MIT's Computer Science and Artificial Intelligence Laboratory, 90% of surgeries designed to remove high-risk lesions turn out to be benign after all. And this means that women are going through, thousands of women going through these painful experiences, this worry, this stress, when actually the lesion was benign. And this technology that we're talking about today is trained to recognise a high-risk lesion and is much, much better. After being shown 335 examples, it has this 97% accuracy rate. Now, if this can be rolled out to
on a mass scale.
I mean,
breast cancer is such a big killer within the female population.
Absolutely.
It is something of major concerns. But what I find really fascinating about this AI technology is that it doesn't just look at images.
No.
It takes into account a lot of other critical factors and information, such as family history, biopsies, pathology reports, as well as any images that can identify lesions or calcifications. as
Absolutely.
you say,
No,
and then make its recommendation. It's not just all down to you as a doctor.
Well, I mean, in medicine, it is a cardinal sin to go completely on an image. You know, yes, CT scans, MRI scans, X-rays, they're fantastic, but they have to be looked at within the context of that patient, that individual. And I think that's one of the discussions that we've had around AI in medicine. Will it be able to take all of those factors into account? And it looks like we are getting there.
Certainly in this particular area, so it holds fantastic promise. I mean, I don't know if there is anything to say whether the trial is going to be expanded or when we might be able to see this technology actually coming into use.
I mean, as far as clinical trials go, so 335 individuals, that's not a significant number in the context of a clinical trial. So it would need to be tested more rigorously to really be proven as something that's useful. But I mean, certainly the indicators are that it will be good, and if we can use this to its full potential, can you imagine the amount of wastage that we'd essentially prevent? I mean, we'd be treating people who actually require those operations,
yes,
as opposed to people who turn out to have benign lesions.
And every operation carries a certain amount of risk with it. So
precisely,
not having to take that risk on just in case, you can. It's got to be a wonderful thing.
Yeah,
Really beneficial.
It's really, really exciting.
And I think if you're interested in that, you can probably read more. It was published in the Journal of Radiology.
It was indeed. It's interesting, actually. Radiology seems to be one of the fields where AI seems to be sort of taking over, and there's a lot of discussion amongst radiologists as to whether they'll be put out of a job and whether the field of radiology will even exist.
Well, we've discussed
in a couple of decades' time.
Great length whether AI is going to put people's jobs at risk, but from everything that I've seen, especially in this area, it's just going to be a powerful tool. As long as it can increase success rates or diagnostic success rates, then you're still going to need radiologists to interpret that data and to really make a judgment call, and then pass that on.
Well, absolutely, and I mean the field of interventional radiology, actually going in under the guidance of an imaging process, for example, in stroke medicine, getting in there and removing a blood clot from the brain with the assistance of imaging. That's the sort of thing that still needs a human input, and I feel that's the way that radiology will perhaps move going forward. But
and that's fascinating. So
it's getting very medical-y.
Less and less invasive, because essentially we're making our bodies transparent using these new imaging techniques.
That's an interesting way of looking at it.
Yeah, you don't have to actually cut the skin and open everything up to see what's going on.
But anyway, I could talk about this for hours, being the medic nerd that I am, so I think we should move on.
Yes, and what an item to move on to. So, earlier this week, we had the world's first giant robot fight.
It sounds ridiculous,
America
but
versus Japan. It does sound ridiculous. When I found this and watched it, I was blown away. It's like Robot Wars on steroids. These things are huge. I can't emphasize how big they are. So the American Megabot was called Eagle Prime. No relation to any Transformers there.
Oh no, none whatsoever.
It was 10.9 tons and stands almost 5 meters tall. It's huge. And I've got to say, both these robots, both the Japanese and the American robots, are manned. They can take up to 2 people, but I think they each had 1 pilot.
Okay.
So they're not autonomous. They're not going to escape and get out and go loose on a killing rampage. So they are mad. They're kind of like a mech warrior style of robot.
Right.
And yes, the American 16-footer, of course, being American, is powered by an enormous V8 engine, about 430 horsepower. And the creators said it cost about $2.5 million to build, and that cup holders come as standard. I mean, where are you going to put your giant mega gulp in your mega robot?
You've got to prioritise.
Yeah. In the Japanese corner, weighing in at a paltry 5.9 tons, compared to the American 10.9, was Sudobashi's Curitas robot. And it stood maybe a metre shorter at 4 metres, but it's still a hell of a machine.
This sounds like a bit of an unfair fight.
A little bit. I mean,
kind of in different weight categories
the
here.
American robot was always going to be bigger and heavier, wasn't it? But if you get a chance to watch the full fight, it is very sort of American in the way they've presented it.
Okay.
But it's incredible what these machines do. I mean, one even has a chainsaw.
So I'm presuming the bigger one.
Chainsaws, claws. Well, no spoilers, so I guess you'll have to watch it to find out which one won.
You're going to tease me with the suspense, are you?
Yeah. Do you like to back an underdog, or go for the clear heavyweight?
Oh, that's a tough one. I mean, the heavyweight does have a cup holder, so I mean,
it does.
That's a bonus.
It does. But yeah, it's just amazing. I mean, it was like watching something out of a sci-fi movie. It's completely weird, but also it looks like quite a lot of fun. So I don't know how long it'll be before you can go down and pick yourself up a megabot to take yourself to work.
Yeah.
And destroy all humans on the way.
I mean, if you had a bad day at work, I'd hate to see.
Yeah, you don't want to get behind the wheel of that when you've had one or two.
Definitely not. But we may be able to keep them in check with this next story about the police in Dubai, who will be riding hoverbikes around soon, apparently.
Oh, that's so cool.
I mean, how brilliant is this? So, hoverbikes have become a reality. Police in Dubai plan to use this technology to help.
Virgin Hyperloop One.
Of course.
So this brings Richard Branson into the game. So now 2 out of the 3 Hyperloops. It's going to become the competition of the billionaires between Elon Musk with Hyperloop Transportation Technologies and Virgin Hyperloop One.
Yeah.
So this is starting to heat up. It's getting quite exciting.
So they've got a big name, a big brand behind them.
A big name, a big brand. And it turns out that the chief engineer of Virgin Hyperloop, Josh Geigel, actually used to be a former employee of Richard's, working on Virgin Galactic. So maybe he managed to persuade his old boss to get in on the action.
Wow. So he left, did something different, went back to Richard Branson and say, hey, what I'm doing is something you should get involved in.
I think you're going to like this, yeah.
I like that.
But the Virgin Group actually does bring a lot of expertise. I mean, even in this country, they run train lines. He's got the Virgin Airline. So they're used to mass transport and moving the public about. So there's probably a lot of marketing and know-how with mass transportation that they can actually bring to bear, as well as just the money and the reputation of the Virgin brand. Absolutely.
And just the name Richard Branson, there's a lot of free PR there.
A lot of great PR. I mean, that man, like our friend Mr. Musk, they know how to play the media and get everybody's attention. So, on that note,
I think
we've reached the end.
We have. That is all we have time for this week. Thank you so much for joining us. You've been watching me, Anjali Pereira.
And me, David Organ.
And we'll be back next week for more technology news. Bye for now.
Bye.